So let's say you have a Bloom filter, or you know you're going to use one, and you want to choose the parameters for it. So the choices you're going to have to make are how many bits to use in your bit array, how many hash functions are you going to hash each item with, and you're also going to have to choose what those hash functions are. You're going to want them to be uniform and independent, and that's a whole other discussion about how you come up with those, but that's separate from the Bloom filter implementation. And then you're going to need to consider how many items you're adding to the Bloom filter, which you'll have less control over. That'll be application dependent, but I'll write it down here. It's the number of items that you're adding. And so what happens once you've chosen these is you start with your m-bit bit array with every bit set to 0, and then every time you add an item, n of these bits get set to 1. So you add your first item, let's say n is 3, 3 of these get set to 1. I'll color them in when they get set, since they never get unset. Then you add your second item, another 3, although not necessarily different 3, get set to 1. You add your third item, another 3, get set to 1. Maybe this time 2 of them are the same as ones that had already been set, and so on. So this is the quantity that we want to minimize. So k we don't have much control over. M is going to be largely determined by space constraints, although Bloom filters are not too large as far as data structures go, and so we will have more control there. And n is the thing that we really have the most control over. If we make n too big, if n gets close to m, then you add a single item and most of the bits will be set to 1 right away, and it will be pretty useless. But if n is too small, then you'll just be setting a single bit each time, and the probability of a collision will be much higher. Sorry, the probability of a false positive will be much higher, because you'll only need one bit to match, or you'll just need 2 items to hash to the same thing, which happens with probability 1 over m, and you'll get a false positive. So you want some number in between, and let's look at some numbers to see how these probabilities come out. So let's say that the number of bits you have